So we will emphasize again how to find the direction of the swimmer's velocity when the object is ending up straight up. So let's suppose that this is the river that we are dealing with, and it is now 230 meters wide. So from here to here is 230 meters wide. And what we have is that the velocity of the current is 7 meters per second. And you are able to swim at 18 meters per second. So the questions that you will see when you are finding the direction of the swimmer's velocity when it is ending straight up means that if the swimmer is starting at point A, then it is ending perpendicular to the shore, and it's ending at point B, that is the shortest point across the river. And there are a lot of assumptions that are done here, that the river is the same width all across, and the current is all the time 7 meters per second, but we are not dealing with it. So now the situation that we will see is that since we have a current that is going, we are assuming on this direction, then the swimmer has to head somewhere in here. But if you cannot see this, then the calculations will tell you. Why I'm thinking, or I'm drawing the conclusion that the swimmer will go between north and west, will be somewhere headed on this direction. Because see what we have. The relationship that we always deal with is the velocity of the resultant velocity is the velocity of the current plus the velocity of the swimmer. And we are looking for the direction of the velocity of the swimmer, knowing that the resultant is somewhere in here. This is the resultant velocity. From this relationship, we can say that the velocity of the swimmer will be the resultant velocity minus the current, the velocity of the current. So the resultant velocity, if we were going plus the current, we will go in this direction. Since we have negative current, then we will go in this direction graphically. So this will be negative current. So that tells us that the swimmer will be from this direction. So this is why I said straight that this is how is it going, because of all this relationship or graphical representation of the vectors here. Since we are dealing with vectors, and now we know that the velocity of the swimmer is the resultant velocity minus the velocity of the current, and we are dealing with 2D, then what we do is we use components. Every time that we have this, every time that we have a 2D situation, the safest way to go is to use the components. So it is the same thing as we have done at any vector A, B, C, D prior to this. So this will be a horizontal component, a vertical component, and then here we have the resultant velocity, negative current velocity, and the velocity of the swimmer. So now, see what do we have here? The resultant velocity is somewhere here. So it's a vector that is going straight up, which means that the horizontal component of this type of vector is equal to 0. And the vertical component is that, whatever is the magnitude of this vector. Is it clear? Now we'll move to the negative velocity of the current. So the velocity of the current is this one. The negative velocity of the current will be, negative velocity of the current will be this one here, graphical. Now, velocity of the current, we're assuming that it's going east, so will be negative, that is from the relationship here, from the relationship, and positive, oops, not 5, it was 7, I think, huh? 7 meters per second. And the vertical component of a vector that lies along the horizontal axis will be equals to 0. Okay? We don't know what is the horizontal component of the swimmer velocities. And we don't even know where is it lying in the northeast southwest axis, okay? So as I said, like graphically, you have an idea. But let's suppose that you are clueless because the situation is complicated and you don't even know, and you don't even see why is it like that. So then what do we say? Something that we don't know in math, we assign them with X and Y, A and B. Whatever variables you prefer, it's fine. Okay, is it clear? The table up to this point is why are we writing those numbers here? So now what we have here is that the horizontal component of the swimmer, that is X, that we assign it to be X, is equal to -7 meters per second. Okay, and this is coming from the horizontal component relationship. Okay, good. So let's work with this now. To have a negative horizontal component means that you have a vector that is like this, -7. And a vector like this is produced either with someone that is between north and west, or someone that is between south and west. But since we know that the resultant velocity is positive, then we can say that the swimmer's velocity is between north and west. Okay, we know that the magnitude of this is equal to 18. So now what do you have is a right angle triangle in which the hypotenuse is 18 and one of the sides is 7. And I'm asking to solve it for what is this angle theta. So then what do is you go, this is in the relation to the angle theta, 7 is adjacent and 18 is always hypotenuse. So angle theta will be inverse cosine of whatever is 7 adjacent over hypotenuse 18. And in your calculator, you can figure out that inverse cosine 7 over 18 is 67.1 degrees. Is this clear? So now from the vertical component, what do we have is that the vertical component of the vertical component of the swimmer's velocity is equal to the resultant component, the magnitude of the result from the vertical component equation. Now the vertical component, 18 here, this was 7, You can find it any way you want. This is the vertical component of the swimmer's velocity, knowing that this is 67.1 degrees. You can find it using a squared b squared is equal to c squared, or you can find using the ratio. I would prefer to use the ratio, so this will be I would prefer to use the trig ratios. So the vertical component of this will be equals to the resultant, which is equal to, or it's the opposite of angle 67.1. So sine 67.1 degrees is equal to the resultant over 18. From here, you can find that the resultant is 18.0 times sine 67.1 degrees. So 18 times sine 67.1 will be equals to 16.6 meters per second. And the direction will be straight up. Questions? Now, if the question is asking you, how long will it take the swimmer to go to point B? Then, as we said, relative motion is a combination of two independent uniform motions, meaning that if you're finding the time in one direction, then you will take the displacement and the velocity on that direction. Now, we know that the river, if I'm not wrong, was 230 meters wide. Am I right? This is what we said. Yes. So the river is 230 meters wide over the velocity on that direction is now the resultant velocity, which is 16.6 meters per second. Why? Because this is what we said, that we wanted the object to go straight up. So now 230 divided by 16.6 will be 13.9 seconds, the time that it's going from A to B. And this will be the most difficult questions that you will see on the river type questions for the relative motion. Clear? Questions? Any concern?